really that 10 by 50 range sort of falls right in the middle there, and that's kind of the sweet spot. That's why we see that quite often. But it does give you an idea of what's available. Now, one thing that a lot of people don't realize is, or maybe they do, some of you might, binoculars are really, really well suited to also look at galaxies, especially the Messier objects. And even though you can sometimes see some of them naked eye, of course, there's quite a number that you can. One example here is the Sombrero Galaxy. So if you have a 10 by 50 pair of binoculars, what you can do here is star hop from, just want to make sure I got the right button. These three stars here, this one's Regulus, by the way. So this is the toe of Leo the Lion. So we're talking mid-May here roughly, okay? This would be pretty much due south, and so you can see, or a little bit past due south, kind of after midnight. But you can kind of go from Spica or Spica, however you want to pronounce it, and just move your binocular just to the edge of Delta here. And when we zoom in there, now you can actually, with the binoculars, a lot of the modern ones are actually 6 degrees now. So you'll find that in some cases you'll actually have this right at the edge of the field of view in a 10 by 50 type binocular, the modern ones. But either way, then you can start to saunter all your way up, and then boom, there's the Sombrero Galaxy. Now, what's really interesting with the Sombrero that makes it kind of a neat binocular object is, if those of you who've seen images of it online or whatever, or even maybe in a large job or something, there's a very bright lane and then there's a dark lane, so that kind of weird contrasting really stands out in the background sky if you get a dark enough sky. But the cool thing is, I'm using a 10 by 50 pair of binoculars, and I'm looking at an object that's 30 million light years away. I don't know about you, but I think that's pretty cool. Okay. Now, a lot of people already know the answer to this, but this is basically the definition of binoculars. Basically, I guess you could almost say like a shortened form saying binary ocular. Really what we're doing here is we're looking through two eyepieces, or two eyes, okay? And the advantages with that is that you retain your stereoscopic 3D depth perception. And there's some real advantages to that. Our ocular system with our 1x binoculars is really geared towards using both of them together. And by having an instrument where you have actually, in this case, twin wide field image directing telescopes going onto each eye, low power ones, that really helps to retain your perspective as you're starting to look through the sky. And that's a huge advantage binoculars do have. The low, medium powers and wide fields of view, of course, also offer some advantages over, let's say, a larger telescope. An example would be M31 that we were talking about before. If you wanted to get the whole thing in the field of view, you can't really do that unless you have a wide field or a rich field telescope. And the nice thing is most binoculars just show it very well. Okay. They're also lightweight, portable, multi-use instruments. And a good example is, besides astronomy, especially if you're trying to get a new pair and convincing your significant other, I really need a new binocular. I want to use it for astronomy, but we can use it for camping, hiking. We can go to football games and use it. There's a lot of different applications for a binocular besides astronomy, so it makes it a really multifunctional instrument. I know these are somewhat obvious, but it's just nice to remind people. In a nutshell, binoculars are truly, really awesome, and I'm hoping by the end of this talk you'll feel a little bit more that way yourselves. Well, if you're not quite convinced yet, you will be. Thanks, Yoda. I appreciate the plug. So I'm not going to get into this in much detail, but very simply, the three areas that I want to focus on here. Most of the modern binoculars, if some of the older members in the group, like myself, when you had earlier binoculars, say in the 60s and early 70s, a lot of them had almost like bakelite or very, very hard rubber eye cups. And so if you did have to view with, let's say, corrective lenses, you'd run the risk of scratching your lenses. The nice thing with the new modern lenses, these are often rubber and they can fold back. So if you do need to use corrective lenses, you're protecting your new expensive, extra eyeballs. And you're also avoiding damaging the eyepiece on the back end, on the objective side, or on the ocular side. All binoculars have a diopter adjustment ring of some form, unless they're an individual focus type, and that's because not everybody has the same vision in both eyes. Very, very rare. So I'm just reminding people of that. And then finally, better binoculars for astronomy will also have this tripod adapter cover, and inside you'll actually see, and a lot of you may already have binoculars that have this. When you take it off, you've got a nice little thread inside the hinge that allows you to mount them onto tripods. The reason for the cap is sort of semi-obvious. It's just basically to keep dirt and dust out, right? So that's all I wanted to say about that. I think everybody's pretty much used binoculars in the past at some point. The heart of a binocular are prisms, and There's two basic types of binoculars, for those of you that don't know. The poroprism, like the one I just showed initially, you have kind of an offset optical path here between the objective lens and the oculars, okay? And it's sort of a double S or double Z configuration. Works very, very well. The roof prisms are the straight-through variety, and they also offer some nice advantages. Mainly, they're a little bit more compact. You usually see them in the smaller size binoculars. They are also applicable to astronomy, but the limit is pretty much 60 millimeters and below. Anything larger than that, the barrels start to interfere when you're trying to bring them together for the average person to use. Okay. Now, another thing that a lot of people don't realize, or maybe you do, you may have seen some of this online already, but VAK4 prisms are what you want for an astronomy binocular. There's some advantages to it. I'm not going to get into all of this, but suffice it to say that the quality of the optical properties of the material are more suited to be able to give a nice round exit pupil, which is what you want. You want to maximize the amount of light coming from the instrument to your eye. Okay? The problem with a lot of the inexpensive BK7 type prisms is that they tend to vignette the exit pupil pretty badly. Usually it's because the prisms are undersized, but nonetheless, I would avoid, in most cases, getting a BK7 equipped binocular. Unless you happen to have one, you could use it, but I would try to definitely go this way. So just remember, BAK4 good, BK7 bad. Yes. Now, speaking of exit pupils, for those of you who we just talked about having as round an exit pupil as possible, ideally for a general utility binocular for astronomy, usually between 4 and 6 millimeters is kind of the sweet spot. Well, you could get like a 7 by 50 pair or an 8 by 56 pair as an example, 9 by 63 where you have a 7 millimeter exit pupil. The reason you want to tend to avoid those, unless you already have them, is because once you start getting to that large an exit pupil, if you're trying to use the outer portion of your eye, it tends to flare worse because there's a lot of optical aberrations near the edge of your pupil and it's really dilated. So you want to use the inner portion of your eye, but you don't want to go too far either. This is sort of the sweet spot when you're looking at a dark adapted eye for most observers. For those of you who don't know how to figure it out, basically you just take the objective diameter, divide the magnification into it, and it gives you your exit pupil. So nice and easy formula there. Now with most binoculars, the numbers are pretty obvious, but you have the magnification and the objective diameter. The large number is always the objective diameter, unless you get something ridiculous like some of these weird Chinese-made zoom binoculars where they're like 20 to 150 by 35 or something ridiculous. But generally, the large number is the objective diameter. One thing that some binoculars don't specify, it doesn't mean that they're a bad pair necessarily, but you'll often see a linear field of view rather than an angular one. And most of the time in astronomy, we want to know angular because we're looking at degrees in the sky, right? Rather than, I don't really care how many feet at 1,000 yards we have. That doesn't mean anything to me. So, because I'm looking at infinity, so how many light years is that? I don't know. So anyway, having said that, what you do is you convert the yards to feet. Some binoculars will have also a metric one instead, where they might be like 114 meters per kilometer or something. In that case, you can use the units directly. And you just take this ratio and take the arctangent, or inverse tangent, and that gives you your field of view. So it's pretty easy. Well, okay, so we've talked a little bit about binoculars, but what can we really see with these instruments anyway? Like, what's so great about them? Well, just even reminding people who get up in the morning early, especially during this time of year and as we get into fall and early winter and then even into the early spring, there's a lot of times when you get up and you're getting ready for work and you look out and go, man, that crescent moon is awesome. And then you can see maybe M40, or Orion or something, and you're just going, oh my God, I wish I had the day off, but I don't. And I don't have time to set up my telescope. Well, binoculars allow you to kind of grab a quick bit of eye candy before you go to work, and it sets a nice tone for there. Or let's say the other way around. Maybe in the evening you had a late night, or maybe you had a concert at your daughter or granddaughter's place, and for their school, and it's getting kind of late. You got to work early in the morning. Well, you can maybe catch a quick 20 minutes of observing, and binoculars allow you to do that very well. Well, you can certainly do this with a lot of Dobbs and other telescopes. It's really easy to bang off Messier objects with binoculars because of the larger field of view. There's some regions of the sky where you can actually get 2 or 3 and sometimes 4 in the same field of view, depending on the binocular. So it's kind of fun. How about seeing a bright asteroid? I'll talk a little bit more about that later. There's several that are well within the range of most average binoculars. Even a lunar eclipse, as we get closer to totality, if you try to look at it with a telescope, it's almost like looking at a new moon. There's not a lot there. But then you look through a binocular, you can still see the nice reds and stuff that you would naked eye. It's quite nice, actually. Well, besides that, maybe having a chance, 2 meteors and 3 satellites go through. I had this happen a couple of years ago, and I was looking, and actually, what was it, about 2 or 3 months ago, I think I told Brian that I just happened to be out, and I caught 2 and 2. And it's just kind of a luck of the draw, right? You have to be out observing, obviously, to have this, but the field of view of binoculars gives you, it's kind of like the lottery, right? The more tickets you buy, the better chance you have to win, right? Seen the closest star to our solar system in the northern hemisphere. We'll talk a little bit about that in a few minutes, too. People can always use a telescope to look at the Galilean satellites, but with a decent pair of binoculars, especially if they're mounted on a tripod, you can follow the motion of the Galilean satellites around Jupiter very easily. It takes a little bit of work when you're new at it, but you know, even if you do, let's say, Jupiter for a half hour on and off one night, and then a couple of nights later look again, it's a good way to just get an idea of the dynamics that we actually have in our solar system. How about seeing a near-Earth object like a near-Earth asteroid? Well, this is a bit of a stretch, and some people might say, yeah, whatever. With certain types of skies, like a dark sight, and if you have mounted binoculars and a decent pair that has decent magnification and digs deep enough, there are certain NEOs that you might be able to catch with binoculars. I'm just trying to do a caveat there because I don't want to come across like I'm lying or something. I mean, there are some caveats there too. Seen a comet in all its majesty. We actually have a couple of comets coming through here this fall, and they're nicely presented with binoculars. Again, because the wider field of view allows you to see the nucleus and the tail, and especially as they get more visible, they're really nice and all right, well, if you're not entirely convinced, I'll just whap off a couple of quick more ones. Mercury or Venus transiting the Sun. Obviously, with solar filters, you have to be a little careful there. The Venus transits are pretty much done now, so don't get too excited until 2017 or something like that. So if some of you youngsters end up getting some special medical thing at the end of the century and extend your life another 30 or 40 years, you'll have a good shot at that. But having said that, Venus and Jupiter in the daytime, very easy to do with binoculars. Obviously, it depends on sky clarity and so on. In fact, this afternoon, I happen to have kind of a light work afternoon, so I went and grabbed one of my pairs, and even though it's kind of close to the sun, I was very careful, and I was actually able to bang off Venus really quickly with my 10 by 42, so really easy to do when you know what you're doing. Seen a lunar flash off the southern polar mountains at certain times of the moon's orbit. If you catch the right time frame, it's usually around 16% illuminated, so it's kind of still close to being new. There's a lot of southern polar mountains that have really nice facets on them. You can actually catch glints that come off as they get into sunrise. They're very quick, they don't last a long time, but you can catch them. It's pretty neat. Maybe the International Space Station, looking at the shape of it, if you're trying to look at, okay, is this really actually an actual space station or what? If you take a pair of binoculars and start panning around, you actually see the outline of the shape of it. Kind of neat. Exploring the spiral arms and dark lanes in our Milky Way. It's very informative. You start to get a really good perspective as to our place in our galaxy by being able to explore regions with our binoculars, because you can actually get the better perspective. Well, that's pretty cool, but is that it? Not really. You're just limited by your imagination. Obviously, sometimes you have to do a little bit of forethought in order to get some of these things, but this is just a sampling of what you can do. There's lots more. Now, I had talked about a near-Earth asteroid, or sorry, not a near-Earth asteroid, a bright asteroid. Vesta here is the one I'm going to use as an example. This was a couple of weeks ago, and just before the weather went really bad. I had a window of about 2 hours after sunset, and it was about maybe 40 minutes after sunset. And you can see, whoops, hang on a sec here. You can see Saturn up here. This is my 10 by 56 Nikon pair I used, and that's a 6-degree field of view. I've been kind of on and off monitoring Vesta all kind of summer, and it's been kind of hanging around within about 20 degrees or so of Saturn. So I use Saturn as a launch point. In this case, it just turns out that it was right outside of the field of view Saturn was in order to find Vesta, and it wasn't really overly hard to do that pair of binoculars. To confirm that I had it, though, what I did is I used my 25 by 100s, and because I had them at the rig too, and sure enough, boom, I knew for sure that I had Vesta. Especially when you're right near the fringe there, when it's not fully dark yet. sometimes it is a bit of a challenge, and the transparency, especially when it's a little lower on the horizon, above the horizon, it's usually a good idea to just take some time to really look. But again, it's possible to see these kind of very easily with binoculars. And in fact, if you use a telescope, you're not really gaining much because these are such tiny objects. Other than maybe having a larger aperture, maybe see it against the background sky a little easier. Other than that, there's real benefit. You're not going to see like craters on the Vesta or anything. Okay, so besides that, two planets that now that we're starting to lose our core planets that we're used to, we were kind of lucky enough to have over the summer. I know Brian's going to talk a little bit about this later, and I'm sorry to steal your thunder a bit, Brian. But one nice area of the sky here, these are basically towards the south, roughly around 11 o'clock or so. And they're almost due south, about maybe 45, 50 degrees up. Uranus here, you can just launch off of Aries, and for those of you who aren't familiar with Aries, it looks like a little hockey stick kind of, the three brightest stars there, and you just go south just a little bit more than a binocular field of view, and boom, there it is. And it stands out fairly well because it's typically a little bit, well, it's more disc-like looking than you'd see on the stars, and there's also quite a different color compared to, say, our standard bluish star. So you can actually find it fairly easily. It's about just under 6 magnitude, so it's well within the range of binoculars. And Neptune, of course, if you star hop down the square of Pegasus here, you can use that asterism on the right-hand side of it to kind of launch over towards Neptune. And I usually use, well, I have been using Psi 1, 2, 3. There's a nice little triangular asterism that makes it really easy to find it. I've got a slide to show that. But again here, so we basically go down from Pegasus down, and here's Neptune region here. Or if you happen to have darker skies, you might even be able to launch from Enif here, and then just take your binocular across and down that way too. So just zooming in on it just really quickly. So there's my 6-degree field of view, and there's Psi, the triangle of Psi 1, 2, 3 Acquarii. And it's pretty much in a 6-degree field of view that's almost at the same distance, or it was at this time anyway. So it made it pretty easy to find. It was one of the dimmer star-like objects in the field of view at the time, so it made it really easy to find, at least from my backyard. All right, so which kind of person would you folks like to be? This poor sucker here, let's say you're a new member and you're kind of trying to decide, you know, what kind of telescope you want. I'm going to beat up telescopes a little bit tonight. I apologize. I've got 5 of them myself, so don't get me wrong here. But one of the big mistakes that sometimes people do is they, you know, maybe get 1 or 2 scopes and go, you know, I wasn't prepared to view tonight, but it's so nice, I got to get out. I really don't know what I want to take out. You know, I wasn't really thinking of looking at galaxies. It's kind of the moon's out. I don't know. Or maybe you're a new member and you go, I don't even know what telescope to get. Well, you can sit there and bandy around all you want, or you can be out viewing the sky with a pair of binoculars. And most astronomical grade binoculars that we have today will run you between, say, I would say a decent pair, you shouldn't pay less than 110 for unless they're on sale, but say 120 to realistically 300, that range gets you some pretty nice glass, and it's far superior optically than you ever get in a telescope in that price range, or even double that price range in a lot of cases. So it's really worth the money to invest in a nice pair of binoculars. You're actually going to see a lot more stuff. The nice thing is, this is me at a star party about 10 years ago with my Canons. And it took me about another half hour after the flash went off to readjust, of course. But it's kind of a cool shot, so I thought I'd throw it in there. Anyway, that's fun when you're able to just go grab and go. Now, one of the big things that I think this is why a lot of new members or people getting into the astronomy hobby tend to really treat binoculars almost like not a serious instrument. But I'm here to say, and I'm sure Jerry will back me up on this one, these are serious supplements to your observing regimen. They're essential tools. You're not using a decent pair of binoculars with you when you're going out. Even if you're an astrophotographer, you're wasting some opportunities, and I'll tell you why. Because if, let's say you're shooting a region of the sky, and you're doing, let's say, 15 minutes of exposure, what are you doing besides that? Playing cards? Drinking beer? That's cool too, but, you know, like, what are you doing? Now, you pull out a pair of binoculars, you've got this beautiful sky in front of you, you go and pan around, you go, holy crap, I think I see some dark nebulae there. Now you've got a new target that you probably weren't even thinking of shooting that night. So you're really wasting some opportunities, not to mention some really nice views. All right, so here's a little mission for us here. Observer's log, start date 201808.2. We've been ordered to the Ophiuchus sector to the 9th magnitude system known as Bernard star. This is the closest one star that's visible in the northern hemisphere for us. Excuse me. Our mission is to observe and report our findings in the region. So I'm just going to kind of just run this through really quick. This is easier to do kind of in mid to late summer because of where the stars are. I think it's almost going to be a real challenge right now to try to do it with binoculars. You can still do it with the telescope though if you want. The summer triangle is a very prominent asterism as well that a lot of you may be familiar with. The three brightest stars here are Deneb, the tailless swan, Vega, which is Alpha Lyrae, and then of course Altair, right? And the brightest of the three here is the launch point here that we usually use. And again, you use a binocular and just walk your way through the stars all the way down. And then you can go to the, now if you can see Ophiuchus directly, you can skip a lot of the steps and just go straight to the head of Ophiuchus, which sometimes you can do. And you go along the shoulder, and this is where we're going to be. So again, what we do is we can, zooming in here, this kind of gives you an idea what the binocular would show roughly. So we have these in the field of view edge, or just outside of the field of view, depending on the binocular field of view that you have. This is 5 degrees here. A lot of the modern ones are now 6, but a lot of star charts will show 5. So, you know, you have to obviously use a little bit of forethought there. But nonetheless, in the center of the field of view, you should see Bernard's star. Now, there's 2 ways to look at it. You could also look at like a dim, dimmer, dimmest, dimmest kind of thing. And in that cascade there, it's in a very straight line, so that will help. But if the star field is just really full of stars, I usually use the triangular asterism here to kind of as a launching point. And it is a bit of a challenge, I won't lie, with a 10 by 50 pair. You have to have decently dark skies, and they should be mounted. If you're trying to hand hold them and do it, I think you're going to have a real challenge because you don't ever get as close to the theoretical maximum light grab with a binocular if it's not stabilized in some form. Okay. So that's a little bit of that. Thought I'd throw some funny things in here. I hope these are okay. So just to recap here, the exit pupil, like I say, should be in the 4 to 6 millimeter range. High quality prisms, the DAK4 type is preferred. Full multi-coatings, I think it's really good to have. In fact, that's essential if you want to have good light throughput, minimize scatter, and have better definition. Most of the modern binoculars that are available now, we're pretty lucky now compared to even 20, 30 years ago, for those of you who can remember, because now we've got, whoops, hang on, I want to go back here, I didn't mean to hit that button yet. Because we have a rubber armoring, and a lot of them are either waterproof or at least weatherproof. And the nice thing is at this time of year, and as we get into this whole winter season into early spring, the likelihood of frost and dew are quite common. So making sure that you don't have water incursion in your optics is essential, right? We also want to, especially for the new members here, you want to get the largest objective size that's practical. So think about how if you're not sure what that would be, go to some stores and just hold a few pairs of binoculars. You don't have to buy any of them, but just kind of get a feel for it. Hold them up, look around, and kind of see if you're going to be fatigued with a 50 millimeter pair. Maybe a 42 is better for now. And then later on, as you get more used to carrying that instrument, you can go to a larger pair. Okay? I also recommend that you get the best you can afford. It's very, very critical that you're better to hold off for a month or two and get a really good pair on the next price point level than pull the trigger and then you're always wanting to know if your binocular is really giving you all you can see. Okay, so it's very, very important. Sometimes people go, hey, there's a deal, I'm just going to go buy something. And yes, I agree. I totally understand you want to get out of view, but at the same time, if you just waited that extra little bit, now you've got something that you can use for a lifetime. That's a quality instrument. So the other thing too is when you're doing a handheld instrument, try to stay in the 12 power or below range. Not that 15 by 70 can't be used. Some of the Celestron pairs, as an example, can be used handheld, but you tend to fatigue your eyes very quickly and your arms in some cases too, because you're trying to hold them stable all the time. And it becomes a little bit of a pedantic exercise after a while. They're really more designed for mounting on the tripod to get the best results out of those. So I would stay below the 12 power range. And then also consider what kind of accessories you're thinking of getting. If you're going to tripod mount them later, or you have a nice tripod mount, and you'll need a belt bracket, things like that. An observing chair, like a reclining chair, even like a zero gravity chair, is really fun with binoculars. You can lay back and you're enjoying the sky, and you're not having to worry about standing still or if you're going to fall off the chair or whatever. It's really quite nice. Well, this is by no means a comprehensive list of binocular brands by any stretch. the imagination. But the common three that most people are familiar with, obviously, are the telescope companies that provide amateur equipment. And they do provide a wide range of binoculars in everything from not so good to very, very good and everything in between. One of the challenges with those companies, though, is because they mass produce a lot of optics, they're not checking each one individually. So it's sort of like the lottery again. You're kind of getting some that might be really, really, you might get a good sample, or maybe not so good sample, or maybe somewhere in between, because they're probably grabbing 100 off of the 10,000 a month to do an analysis on. And so that can be a bit of a challenge, so just be mindful of that, okay, when you're looking at getting a pair. These other companies like Nikon, Fujinon, and Canon, they also manufacture, obviously they're well known for camera equipment as well, and they make fantastic binoculars, but they don't come cheaply. You're probably going to be looking anywhere minimum, probably in the 200 Canadian range on the low end of the Nikon, all the way up to, well, 2,000 plus for some of the higher end Fujinons. Okay. Canon image stabilized binos are really nice. I've got 2 pairs, I'm not trying to brag, but they run about $1,200 each. And they're very, very nice binoculars, but if you don't have the budget for it, it doesn't matter. You can certainly do very well with a standard pair too. You just have to work around it. And then these companies down below here are really well known for high-end optics as well in Europe. And Swarovski is really well known, and so it's nice. Some of the smaller pairs can even fetch $2,500 like on eBay and Amazon. You're kind of getting diminishing returns. I mean, it's like buying a Porsche. If you get the performance, but it's really it's because it's a Porsche thing or something, or Porsche, sorry, I should say. Now this is one website that's actually very, not too bad. It's got one nice thing on this one is they cover a lot of different binocular manufacturers, way more than I cover here. And so if you happen to come across a pair that looks really esoteric or you never heard of it before, you can usually, there's a good chance you'll find it on here. Now, a lot of these sites will have both the hunting and birding with the odd astronomy review in it. If you don't find anything for astronomy for a binocular you're interested in online, look at the birding reviews, because birders typically will have the same kind of requirements we will as astronomers. They want to have good quality images, low chroma, a nice sharp field of view across as much of the field of view as possible, things like that. So, and good color rendition, right? So if it's a good birding binocular, there's a good chance that it'll be a good astronomy binocular as well. And if you do bird watching, then hey, all the better. There's also cloudy nights, and there's a lot of other review places as well. Now, just speaking about brands, I just want to mention one that sort of stands out a little bit. I've owned several of these over the years, and I bought a large Overwork binocular in the spring. I've been having a lot of fun with it. But Overwork actually checks each of their binoculars that go out the door. They actually have a special collimation check, and they can actually make sure that the binocular is properly collimated. An incorrect binocular, collimated binocular will actually give you eye fatigue, and you might actually get headaches if the alignment isn't done right. Plus the image quality will be worse too, a little bit. So that's very, very important. So I just wanted to mention that there's not a lot of companies that do that kind of thing. Now, having said that, I did talk to Kevin Boussero, because I have bought several binoculars from him. I told him I was doing a talk tonight, and I asked him, well, of your kind of, binocular, I mean, you've got so many, but what would you recommend that stand out, or what are your most popular ones? And he mentioned these three as, like this 11 by 56. I've actually owned 2 of these over the years, and they are an excellent value. They run about 130 Canadian, maybe about 150, 160 with shipping, but they are a fantastic binocular. They have a little bit more jam than a 10 by 50 pair, but the nice thing is that they're just a really good pair. Like the optics are very, very good on them. And I used to bang off bright carbon stars with them many years ago. The deluxe versions, what's really notable with these guys, even though they're a lot more money, and I'm sorry if you're panicking going, oh my God, I can't afford 250 Canadian for a binocular right now. The nice thing with these, though, is that they're threaded for filters, which changes the whole dynamic on a binocular now, because now you go out under the sky with, let's say, some nebula filters or a moon and sky boat filter. Now you've got a whole different regime of viewing. Okay, so it's kind of neat to have that capability, and my large binocular pair does as well, and it's really fun. It's kind of neat that way. They're also fully waterproof and nitrogen purged, and they have a generous field of view. The 15 by 70 here has just a tiny bit smaller field of view than the Celestron 15 by 70 pair. They're at 4.4, I believe. That's not enough to be worrisome, but I just thought I'd mention it. I asked Kevin as well, I said, well look, I'm going to be doing a talk, and by no means I don't work for Overwork or anything else, but I just thought, hey, while I'm talking to Kevin, I might as well put a plug for our RASC group and see what he can do for us, right? Every little bit of saving helps. So I've asked him, can you offer anything? He said, yeah, I'm willing to do 5% off of everything, including this high-end stuff. So, you know, he sells stuff upwards around $2,000. So for those of you that do have deep pockets, that's a sizable savings. At least it covers the GST. So take a look online if you see something that you like. They're usually pretty good about getting a hold of. You can usually ask a lot of questions, and they're willing to answer some things. But they do make some nice pairs. So they're worth a thought anyway. All right, so just for those of you who are a little newer or maybe haven't owned a binocular, I'll rifle through this really quick. It's fairly common sense, but this is how I set up binoculars for best results, especially if you're at a star party and you're passing it around a lot, like people are, you know, changing the pupillary distance, they're tweaking the diopter. So you gotta get it back really quick to where you want it. I just cover the right objective where the diopter is, and I look through the left-hand side, get the proper focus, and then I just cover the left objective, and then I look through the right-hand side and I just adjust the diopter alone. I leave the focus alone because I've already focused it. That's typically what you do to set it up anyway, but it's a very quick way to do it when you have the caps handy. And then you just tweak the interpupillary distance, mainly because once you've got it properly in focus, you may not have the pupillary distance optimized yet, and then you're good to go. So I know it's fairly simple, but I just thought I'd mention it for those of you who are struggling with pairs of binoculars. It's more critical when you get to higher power pairs, because smaller changes are really, really more critical. So again, which type of observer would you like to be? This poor lady that's praying to the sky gods to help her find her object through her tiny little knob? Or this poor guy here who's waiting for Polaris to sit there and he's trying to do a manual mount? Looks like a pretty nice telescope, but he looks a little lost, doesn't he? Or you want to be these cool guys, eh? Well, we don't need Polaris, eh? I mean, it's awesome. So again, like I said, I know I'm beating up telescopes quite a bit, but binoculars are just a lot of fun. And I think if you really give them a chance, for those of you that hold them, hold them out once in a while. I think you'd be very impressed with what you can see with them. Now there's a couple of really interesting accessories that some people may not be aware of, so I just thought I'd point them out really quick. This one sounds like kind of a quirky thing, but it's actually pretty neat. So it doesn't just work with roof prism binoculars. You can use this also with Oros, but it's mainly designed for roof prism. So if you have a roof prism binocular, as an example, quite often they're more suited to hand holding than tripod mounting because they tend to be a little back heavy. What this does is threads into where you would have your tripod adapter, and you just set them, once you have your interpupillary distance where you like it, you just set the tongs, there's little tooth tongs on it, you set them where they rest against the barrel, then you tighten it up, and then from then on, when you pull out your binocular, if you just need to have a quick grab and go, you can just go, put it together, focus, you're done. Really nice. Some other accessories that are somewhat obvious for some of you. We talked about tripod mounting. Well, an L bracket is really essential. I prefer the metallic ones that are either alloy or aluminum versus the plastic ones. I know a lot of companies will offer a very inexpensive L bracket adapter. It tends to be very vibration prone. And when you get into colder temperatures, not a good idea, because if you happen to bump your binocular, you might even snap it. The last thing you want is your premium glass going smack into the snow, maybe onto the concrete or something, or the dirt or whatever. Another accessory here that a lot of people, hang on a second, here, I went too far. Whoa. Okay, went way too fast, right? Hit the wrong button, sorry guys. I'll get used to this yet. Anyway, is this little pistol grip. It's kind of cool. I discovered it, I was using it for one of my cameras, and I thought, hey, I think this would be pretty cool on binoculars. I have a friend that I picked up one for. He has a set of Celestron Skymaster 15x70s, and he normally tripod mounts them, but we thought we'd just play around, and he actually had this Orion adapter already, and so we put the two together, mounted them on it, and balanced almost perfectly, and it was actually, I'd say 3/4 maybe to using my image stabilized cannons. When you're sitting down, you can actually stabilize them really nicely. It was quite impressive actually. And it's kind of fun to use because, like I said, you can even hold it with one hand if you needed to tweak something really quick, and then, you know, just kind of carry it around. It's really quite nice. Anyway, you could also go with a parallelogram mount with a tripod, or a large tripod, instead, like a camera tripod with a pan head, and then use the L bracket to mount it on there. There's different ways to mount your binoculars or use them. The parallelogram mounts will run anywhere from, say, 200 or 250 on the lower end for the lighter weight ones to upwards around 500-600 or bit more in some cases. So again, you're probably looking at least the cost of a binocular for that. But the nice thing is with this little bracket here and it being counterweighted, you can share the view without losing perspective of your target. So if you have kids or it's a public outreach, you want to share the view, it's a really good way to do it. Okay. But anyway, whichever way you decide to go, a zero gravity chair really enhances, as I mentioned before, your binocular observing experience, especially if it's stuck closer to the zenith. It's really hard when you have a tripod and you're looking up. If it doesn't go high enough, you got to sit in a chair and you're trying to get a view straight through. The chair does a much better job. You can just lay back and enjoy the view. Some books that are available for binocular astronomy. These are just a select few. I own this one, and I have owned an earlier version of the Touring the Universe Through Binoculars by Phil Harrington. Both very good books. Sky Vistas is really nice because there's some nice pictures. Does anybody have any of these books by chance? Show of hands. No? Not even Jerry?
Yeah,
I'm just kidding. Okay. Anyway, but they're all chock full of very good information, different objects that are really well suited to binoculars, both star clusters and nebulae and deep sky stuff. Very, very nice references. There's also another one that I particularly like, and this isn't really necessarily geared towards binoculars per se, but I thought I'd point it out. It's the Peterson Field Guide. And what's really nice about this, for those of you that remember the size of a VCR tape, that's about the size of the book. For the younger members, ask around. Anyway, it's about an inch thick, and like this by this, but it's chock full of it's got moon maps, star charts, little blurbs and regions of the sky on the opposite page to the chart. It's got the Messier catalog, Caldwell, select double stars, planetary information, asteroids, you name it. And they're usually good for a period of time, like usually about 8 years or so. I think the latest one is good to 2020, and it'll give you optimal rise and set times for planets and all sorts of stuff. I know that our RASC Observer's Handbook probably has a lot of this stuff in it, but it's just a nice portable field guide that you can carry out and take this, zero gravity chair, a pair of binoculars, and just a little red flashlight. You can have a heck of a lot of fun. I've done it on several occasions. It's really fun. Okay, so another book that's very good, and this website's really nice. So for those of you that are kind of getting the itch to go and maybe rediscover binoculars, or those of you who are newer in the audience that are thinking, okay, maybe these binoculars or something to these. Binocular Sky is run by Stephen Tonkin. He's sort of a semi-professional out of the UK, and he has a site dedicated to binocular astronomy. And the nice thing with this site is they have custom observing lists you can print off. He's got an interactive sky chart. There's some really neat resources there for binocular astronomy. And he has a few reviews on a few pairs that are available in Europe. We don't see them as much here, but there's equivalents. You'll recognize some of them. But his book as well is very interesting. This one I just ordered actually. It runs about $54 at Indigo. And I haven't received it yet, but I'll let you know sometime if you're interested. But it looked very interesting to me. The first, maybe third, covers more technical aspects of binoculars, how to evaluate them, some of the mechanicals and more detailed optical information on them. And then the remainder of the book is featured by Sir Patrick Moore, talking about some of his practical astronomy series and focusing on binocular targets and stuff. So I'm looking forward to getting that one. Whoops. So whichever way you decide to go, for those of you that are new, or for those of you that are currently using binoculars, if you have a smaller handheld, or you have a larger mounted size, like yours truly there looking at the rising moon a couple of weeks ago, and we actually did have sky, I certainly hope you'll try to double your fun under the stars. So that's pretty much it in a nutshell. Thanks. Just before I go here, are there any questions? Does anybody have any questions at all?
Where can you find bracket?
An L bracket? What size binoculars do you have? 10 by 50? Come see me at the break. I'm going to be I was just going to mention, I'm going to be setting up, I've got a few giveaways and some things for binoculars. So come and see me during the coffee. I'll set us kind of out of the main traffic zone so that people can come and see me. And especially the newer folks, if you're, say, 5 years or less in the hobby, I'd certainly like to talk to you. If you don't have a pair of binoculars, you're going to make some recommendations. Thanks, guys.
Thanks, Darren. Yeah, if you do have any questions for Darren, feel free to come up during the break. We can talk more about it. Welcome again to the rest of you that have now shown up. This is the October Brendan. I will be hopefully running the show tonight. I don't know who's going to introduce me for the presentation, but I'll just do it myself. Are there any, is anybody new? Any first timers? Hey, cool, welcome. Come say hi at the break if you want. I'm happy to chat about anything, anything generally, but preferably RASC related. So for tonight, real quick, we just had a very excellent session on binoculars and a good way to get into astronomy. I'm currently one up here for this section, which is the announcements, so I'll be running through that. Jay Anderson will be giving us a Lost in Space, which is a look at maybe a slightly lesser known spacecraft floating around the solar system, one you haven't heard from in a while. As Darren mentioned, Ryan will be doing our What's Up as usual, and I see Ian preparing a What's New up there. So Ian will be giving us a What's New on the science of astronomy. Then we'll have a refreshment break, and then I will be back to talk about Halloween. Actually, do we have calendars left?
Yes.
Okay. If you want a calendar, I've heard inflation has taken effect, and they're up to $13 now.
Yes.
So, if you'd like a calendar, see Stan, $13 gets you a calendar.
Yes.
We actually have there's a Winnipeg member that actually has a Kevin Black. He's got a picture of it. It's quite nice. There's also this book. Ralph's here tonight. Ralph? Okay. If you're interested in this book, reach out to me. You can just use the website. Ralph wrote a book on meteorite hunting and collecting. I haven't had time to go through it myself, but from what I've leaked, it's good. But Ralph really knows his stuff when it comes to meteorite hunting. Collecting is definitely a passion of his. So if you are, he's a member here. So if you're interested in it, just feel free to reach out and I'll put you in touch. U of M continues to host their open houses. They're the last Wednesday of every month at 7 p.m. Currently being held in University College, room 240. The next one is on October 31st. And they'll be talking about Pluto. Oh, this year?
Dark stuff.
Black holes? Okay. So the topic has changed. Halloween thing, you gotta have something Halloween thing. Apparently it's been changed to dark matter, black holes, dark things. I don't know, I think Pluto's kind of spooky, right? Sure, why not? Anyway, but that'll probably follow for another one. Okay, anyway. But go check that out if you're free on the 31st. Okay, on March 9th, this has started back up as well. I was looking at the website, and I think their next one is going to be on birds. They're going to be doing a talk on birds and how they actually use they do their navigation for migration and stuff like that. So kind of a neat thing. If you're an RASC member, if you show up with a telescope, they'll let you in for free, and you help out with all of the observing, assuming it's clear. It's a good way to get out. Okamus is a fairly dark spot, so it's a good place to be out there. Telescope loans. If you are a member, we have a few telescopes that are available for you to loan 1 month at a time. I certainly didn't realize it because I didn't bother thinking about it, but I had the solar scope out for the past month. Could use that then. I did actually have it out of school, where it was probably the most plain, boring sun. It's not very active right now, but the kids thought it was cool, so that was neat. Anyway, we do have a solar scope available. We've also got, sorry to blind you, we've got these two jobs as well, which if it does start to clear up, these are fantastic scopes. We talked a lot about binoculars, but the 8-inch job is a very easy intro level scope, very easy to use setup. The reduced field of view does make it a little bit harder than using, say, a pair of binoculars, but they're still really good to get into, and the price is pretty good. Like I said, they're free for you to take out for a loan, if you're a member. Lonely Observatory is another member perk. This is our observatory south of the did tell me that he won't be doing a members observing night tomorrow. I'm going to guess because of the weather. But it looks like it might be clearing up in the next week or so. So he said maybe next week he'll definitely be sending an email out should anything come up. Also, the Explore the Universe program. This is a program that the RASC puts on where you can get a list of objects and go and observe them, and record a log of what you see. Send that to the RASC, and you get a certificate for it. Really, what you're getting is not the certificate. You're getting the satisfaction of learning the night sky and taking notes and having a good reason to go out and be under the night sky. I do recommend it. It's a really nice guided way to get yourself out under the night sky. Even if you're not intending to go for the certificate, it's actually just a good list if you're starting out. There's some really good beginner objects in there and some details on how to find them. So if you're interested in that, I recommend either reaching out to Dennis, you can reach out to myself as well via the website, or just going to rasc.ca/explore-universe. Recommend giving that a shot. I did blow through this pretty quickly, but does anyone else around have any other announcements that I forgot? Okay, that wraps it up for announcements.
Brandon,
Sorry?
there's another shipment of Sky News there.
Yes. Yes,
For
good one.
people to take and pass out.
Yep. So if you're a RASC member, you're already getting these. Okay. So you don't need to take one for yourself. But I do recommend taking them, dropping them off at school, dropping them off at work, dentist's office, doctor's office. We don't have to be there, but
Hand them to your kids to take to his school. And then there's all these other movies.
yeah, there's some other magazines there as well. Yeah, so as I said earlier, Jay's been doing these Lost in Space segments, and they're pretty neat. They take a look at a spacecraft that we haven't really heard from in a while, or maybe gets a lot of attention in the academic circles, but not much elsewhere. So I don't really know. Lies. That'll be a good one.
Am I live?
Okay, take it away, Jay.
That's a rhetorical question. Okay. Lost in Space is for those spacecraft that have, for the most part, become defunct. And they're just left lying, sometimes in orbit around the sun, sometimes in orbit around space. And today we're going to talk about WISE. Now, WISE is one you've probably seen, a Wide Field Infrared Explorer. So this was a satellite that was basically put up to do a survey in 4 infrared bands of what the sky looked like. And it was kind of an interesting thing. It was a pretty small telescope, but it was launched in 2009, worked for 2 years. When the hydrogen in it essentially evaporated because they used a solid block of hydrogen to cool the infrared detectors, which is what you have to do to get sensitivity in some of those wavelengths. And it had 3.4, 4.6, 12, and 22, so quite a range of wavelengths there. Generally, these will be hotter objects on the low end of the wavelength side, and they'd be cooler objects on the high end of the wavelength side. Small telescope, and it was kept cold with that solid hydrogen. When that ran out, you couldn't use it at the 2 lowest wavelengths, but these 2 still worked because they didn't need the cooling that the shorter wavelengths needed. So first they put it into hibernation for a while, and then they restarted it, ran it for another 4 months to look at things like near-Earth objects, asteroids, and things like that. Quite an interesting or ambitious project took an image every 11 seconds, and it was always pointing away from the Earth. And they wouldn't. The only thing they avoided was the moon. The moon was too bright for the sensors on the satellite. 6 arc-second resolution, so pretty decent resolution, and a field of view that was 1.5 times the size of the moon. You've probably seen these images. This is a sort of mosaic of, I think, the first 4 or 5 months of observation. And the way they show it in this and the other images I'm going to show you is that the smaller wavelengths are usually colored blue. So those are the hot objects, and generally they're stars. And then various shades of green and red and yellows indicate colors that are of warmer objects. And you can see that for the most part, this is, you have to think about this is actually an image of the entire sky around like this. So at one point of it, you're looking in toward the center of the Milky Way, which is what this area is. You see the small bulge here, some gas clouds that are up high above. Well, when you're looking away from the center, you're looking out in these directions. And of course, you have Magellanic clouds and the occasional galaxy that's visible in this low-resolution view. But when you zoom in on it, that's when you start to see a lot of stuff. And I'm not going to read everything that's on this slide to give you an idea of what the images show. But going back to what we talked about before, blue objects are the hot objects, and you can see these tend to be the stars. But there's a lot of other things that appear blue too. Quasars, nuclei of galaxies, which are very hot, exploding stars, remnants. There's a lot of things that punch the temperatures up into the 50, 100,000 degree Kelvin range and even higher. So the blue objects will sometimes appear in here, so either nebula or surrounding very hot stars. So what we're looking at here is basically a gas cloud, a stellar nursery, as it says up in here. So the green ring is the cooler stuff. This is small particles of warm dust. It looks like smog on Earth, according to this. Red cloud is more metallic, a different composition, something that absorbs the ultraviolet light from this star than these other stars a little more extensively, and so they heat up a little more. In here we have one particular star. It has a lot of stellar winds, and so those blow outward from the star and they collide with the dust and gas around that star and heat it up, and so it gets a mixture of colors in there. And finally we have this stuff in the center. It's just a little bit cooler than the hottest area right in there. So from looking at these images, you can just tell from the color, and of course the color is optional, it depends on who's doing the programming, but they consistently use the same color scheme, so you can see right away whether you're looking at hot dust or whether you're looking at a very hot energetic processes, or whether you're looking at cool dust. So one of the things that they went looking for were these things called hot dogs. Dogs are dust-obscured galaxies. These are galaxies that are essentially invisible wavelengths, but which are very prominent in infrared wavelengths. And the reason is that they're surrounded by a lot of dust, and the dust is heated by the galaxy behind it, and so you see the glow of the dust in infrared, whereas you see none of the visible light wavelengths. These are very, very bright galaxies, some of them the most luminous galaxies that we know of, and yet we don't know of them until we saw them with the live satellite. So here are pictures of them, and you see where they've identified a bunch of regular galaxies here, and this particular one with its hot red color, and here it is in the 4 wavelengths, so you can see the 2 short wavelengths, it's invisible, or virtually so, and it's only when you get into the wavelengths that are looking at the radiation from somewhat cooler dust that you start to see it, and especially in the longest wavelength here at 22 microns. So they show up very dramatically as you get longer and longer wavelengths, and that's partly because the wavelengths themselves are able to see deeper into these dust. You're not looking just at the surface of it. And we'll see later on that invisible, some of this dust is quite opaque. Here's another thing that WISE identified. We're looking for quasars, millions of quasars. Quasars are the hot cores of galaxies. They're black holes, masses millions to billion times of our sun. They're pretty common to the point where when you go looking out in them, you see how many they've outlined here, although it doesn't really show very dramatically. But by comparing their brightness in those 4 wavelengths, and especially in the 2 smaller ones, you see that they're extremely hot objects. And you can go looking for them in the visible and identify the galaxies that they belong to for the most part. So this is essentially material falling into a black hole and being heated up as it gets into the intense gravitational field of the black hole. Here's another image here. This one is around a star called Java. One for you, Jerry. You'll have to find it the next time you're doing the binocular tour. It's in Scorpius, and this is a grid that's 8 times the size of the moon in each direction in here. So we're looking at a rather massive area of the sky. You can see the description here. You can read that. Basically, think back about what we said before. We're looking at a hot object in here, cooler gas here. We're getting back into the red tone, so there's some hotter parts over here associated with some of these brighter stars. And then all through the background, these very bright hot objects, some of which are stars and some of which are quasars, and so on. Down here in the corner, we have a hot star, and it has a little tiny bit of dust on one side of it, and that's believed to be a shock wave around that star. The star is moving extremely quickly, and we'll get a better example of that in the next image where we have one of these shock waves from a different star. This is a high velocity star here, moving at something between 680 and 4,200 kilometers per second. So it's really screaming through the galaxy. It's got a very, very hot and fast-moving solar wind around it, or stellar wind that's blowing outward from this. That's running into dust and gas that's in the galaxy that it's traveling through, creates a shock wave and makes that stuff blow just like a bow wave ahead of a boat. We'll get into something a little more familiar or unfamiliar. Many of us, some of us have taken pictures of the Pac-Man Nebula, and this is what it would look like after an hour or 2 of exposure. Here's what the Pac-Man Nebula looks like in these infrared wavelengths. The first thing that happens is that the infrared wavelengths are long enough that they pass right through the dust and gas that obscures parts of the Pac-Man Nebula, so it's as if it's not even there. In fact, I don't even know what the correct orientation of this is to match this. You can't match the stars up very well because sometimes the stars are cool enough that they don't appear as blue. Especially if they're partly obscured by some of this dust and gas. And whereas you can have very faint stars in here that are extremely hot and they really show up. So it throws off your star field. But anyway, you can see that there's quite a bit of detail. You can see these columns that are sticking in towards the middle. These are actually columns where the dust is a little thicker, and so the hot or the ultraviolet light from the central star is burning away the dust and gas and evaporating it, but when it runs into these very dense clusters, they shadow the area behind it, and so you end up with these large columns that point in toward the central star. A very nice structure. So you're looking at the object itself. You're looking at the dust and gas and the hot stars in the center of the cluster that make up the entire object rather than just the part of it that's illuminated or caused to fluoresce in visible light. Here's another popular object that we've seen, the Lagoon and Trifid nebulas, and here they are in here in considerably more detail. And of course, the farther you get away from the central cluster, the cooler the dust and gas is and warms up quite dramatically in this very, very dense object here as you get in toward the center. So what it does is it gives us an entirely new perspective on what we're looking at in what are otherwise fairly limited wavelengths in visible light. here's the flame in the Horsehead. So here's the challenge for you. Where's the Horsehead Nebula in this? So we see the Flame Nebula is here. And we know the Horsehead's somewhere in here, or at least should be. Of course, every one of us has seen the Horsehead Nebula. But in this, because the Horsehead Nebula is warm dust, it's giving off light. It's emitting, and so it shows up. But it's actually this tiny little notch right in here. It's the only evidence of it in this image. If you look at galaxies, the color is mostly blue because the energy coming out of these galaxies is primarily from stars, and so they're very hot objects. But even there are things that are hotter than the rest, where there are places where stars are very actively being formed. Some familiar objects, this is the Sombrero Galaxy. When you look at that in the visible light, it has a nice sombrero shape. When you look at it in infrared white, where you're seeing through the dust and gas, you can see that it's almost Saturn-like in its appearance. And here we have M60 is one of the brightest galaxies in the sky, but this is M60 here. This is a small companion galaxy that's in the background beside M60, and in fact, it's much, much more prominent because it's got a much hotter stellar activity and stellar formation going on in the center. This one's no surprise, as though we're all familiar with M51 and its companion, and it's showing the spiral arms quite nicely because that's where the stars are. So in the end, what did WISE show us? Well, it couldn't find Planet X, so it's pretty much limited how big Planet X can be. It's back in the news again. Somebody's still looking for this planet way, way out in the solar system. Nothing the size of 2 times Jupiter would have, anything as big as twice Jupiter or bigger would have been seen. We found a new class of very, very cool stars. The temperatures are about as hot as you and I, and they're not going to burn away very quickly. All those black holes, the hot dogs we talked about. They found the most luminous galaxy, and another one of these infrared ones that doesn't look particularly interesting in visible light. They found 20 comets, 33,000 asteroids, and 134 NEOs. So let me just have a pass back here. Sorry, go one more forward here. These 2 arrows I put in here, not very visible. There's a green dot here, and here, and here, and here, and here, and here. Over here, there's another string of green dots. Those are asteroids, because each one of these images is made up of 8 separate images. So the asteroid, which is cool, moving through this field, shows up as a line. And that's one of the main functions of WISE, was to find these galaxies, and it did so just by taking these individual exposures and seeing it moving. And after they had gone into the separate neo-WISE or new WISE, as it would be translated, they found 134 near-Earth objects as well. You can go into the WISE website or into their archive and pull down images. They got this form you fill out. I put M42 in it and started to pull down the images of M42, and it told me it would take 39 minutes to compose the scene I wanted. And probably I should have read the thing up here that says instructions. But I'm a man. I don't read. So tell me what this is. A few things that looks like it's invisible. Kevin. You must have photographed that a whole bunch of times. The Veil Nebula and its parts. Thank you very much.
Yeah, we got rid of most of that, actually. East? Snow. Yeah, snow. It does, the forecast does actually look fairly good for, for next week. So, those are number 1. Okay, take it away, Brian.
Thank you.
discuss what's on for this month of October. For some of you that are new, I just wanted to point out that I'm Brian, I'm the director of the observatory. So if you have any questions, bookings, or anything like that, you can come see me. I'll be sitting over there. So during the break, if you have any questions, please do. I don't have any keys cut right now, but I will get some later. So let's start off with the planets, shall we? Wait. There we go. Oh, that went too far. Okay. Okay, obviously we have some. Okay. Is that gonna play now? Okay, anyways, we'll start off with planets. Got to go on there. Okay. Planets. Planets doesn't look very good this month. Most of them, like Jupiter and Saturn, well, not Saturn, actually Jupiter, Venus, and Mercury are mostly daytime planets now. Well, Jupiter might be more like an evening twilight, but later on we will have Saturn and Mars. Again, early evening, so, but unfortunately, my sad thing about it is I'm losing Mars. I love Mars, one of my favorite planets, but unfortunately, that's going to disappear. So all these planets are going to be daytime real soon. So hopefully the next observing night will still catch a little bit of Saturn and Mars, but we'll wait to see next week. This is kind of like a top view of the planets. The planets are rotating counterclockwise. It's going to give you an idea of what I said earlier. So we do have Mercury here, Venus, Mars. We're spinning in faster than Mars, so we're losing Mars. And Jupiter and Saturn don't really move much here, but it's kind of give you an idea. They'll be kind of like more like the evening day planets. I don't mention Uranus or Neptune because they're pretty hard to find and locate. All right, so what do I have here? So this is tomorrow. I thought it was kind of interesting because we have a little bit of moon there. We got Jupiter, like I said, it's during the day. We have Venus and Mercury. I didn't have time to take a picture of it, but apparently you can observe the planets during the day. Darren showed me a picture of it, which is pretty good. It's a little washed out, but you can make out some of the details of Jupiter. But you gotta be careful of the sun, though. Really careful. Okay, next. Wrong button here. Okay, so in the evening, we did have our observing night tomorrow night. Oh, I'm missing something here. Okay, I kind of highlighted it a little bit here. So this is Mars, and right here this is Saturn. So this is roughly, what, 8 o'clock, I said. So we still can view some of the planets, but like I said, Mars is moving away pretty fast, away from us. So we're going to drop, it's going to drop down in magnitude quite a bit. So what do I have? Oh, I did have it. Okay. That's all I have. I tried something new. All right. This is something that Darren put together the last minute on Thursday night. So what we're trying to do is, especially for the new members, like we're going to point out, especially during the members' night, trying to point out some of the more objects that you can view, not only with the telescope, but with the binoculars. Okay, so we started off with the double star cluster, which is next to the constellation Cassiopeia. Their NGC 869 and 884 is the number for it. Next, we have the constellation Perseus. There's no object there, but I don't know. I guess it's pretty nice as a binocular view. Next, we jumped into Auriga, which is the M36 object. Auriga has quite a few star clusters in it, almost vertical, you're looking at directly. So again, it's another eye-candy kind of constellation to look to. The first time I looked at it was back in Comic Marsh, some years ago. We needed to point out some object for the people, and it worked really nice. That's next, we jumped to M45. Pleiades, constellation. Oh, sorry, I went a little too far there. The Pleiades, okay, M45. Again, if we have the member site, I'll be happy to point this out with a laser pointer or with a telescope. Next, of course, finally, Andromeda Galaxy. What we've done here, and I learned it the same way too, just like Darren did. Okay, you got the square here, you just jump over to 2 stars, and then up 2 stars again, and then you have Andromeda Galaxy or F31. Again, I'll be happy to point it out. I did try this at one of the star parties a number of years ago to see if I could see it through the naked eye. Yes, you could see it. It's kind of a fuzzy patch, but it's a nice object. Okay, what do we have for events for October? I didn't include the full moon for some reason. I just hate the moon right now because it just not helping right now. Okay, so the new moon was October the 9th, and October 13th we have the zodiacal lights coming for the next 2 weeks. I'll mention more about it later. Next we have the Orionid meteor peaks that's going to happen on October 21st. Fortunately, it's not going to be very good for this month due to the moon. That's probably why I left it out. I don't know why, but of course we have Venus, and this is kind of interesting. We have the moon. It's going to be 1 degree from the Beehive cluster. So next I'm going to talk about, I like to bring this up because the month of October, we should have almost every single night at least some meteors happening, going through the sky. So just kind of the overlap here, this is Orion meteor shower here, of course, the moon's going to be at 90%, so kind of wash out. Like I said, they kind of overlap each other, so hopefully this month you might be able to, if it's clear that is, hopefully we'll have see some meteors, sorry. All right, now I tried to look this up for the comet 21P. The brightness is about 8.1, but I haven't been able to look at it. I know some people at the star party was able to look at it, but I haven't been able to look at it because of the sky and whatever, I had time to look at it. So hopefully it's right next to the star Sirius, right here. So it should be relatively easy to find. That's tomorrow, actually Sunday morning. It's going to start to rise around 2 a.m., but it's going to get high enough around 6 a.m. to view it. But if it is clear, maybe we'll be able to see it. But I don't know how it's going to look. All right, the Orionid meteor shower. Okay, just little highlights here again. We do have the moon to compete, so it's pretty much a lost cause, I think. Hopefully, if it does happen, it was clear. We're going to have about 2 meters per hour. And of course, one interesting fact about it was it comes from the debris of the Halley's Comet, which I find that fascinating. Of course, it's right next to the constellation Orion. Next, the zodiacal lights. It's a lot of information here. I should condense it, but it's interplanetary dust. When I looked into it some years ago, it's the dust that's left over from the creation of the solar system. So it's a soft, white, kind of a pyramid light. I'll show you a picture taken in Arizona. Basically, it follows, the point of it follows the ecliptic path of the sun. I'll show you again more about it. It only occurs spring and fall, but it's only when the geometry is right. And the geometry in this time for fall, it's going to be just before the twilight in the morning. Okay, what does it look like? How do you view it? Okay, well, the brightness is supposed to be a little bit brighter than the Milky Way. My first time, I remember seeing it when we pulled off the road. Got to look at it in Arizona. I had a hard time looking at it for the first 10 seconds, and then I came across it. So you might get it confused with some light pollution or something else, depending on how experienced you are. But again, I'll point it out if we do have it during night and do stay up that late. I'll be happy to point it out. But even the most experienced astronomers have not even seen the zodiacal light. So don't be ashamed you haven't seen it, but if you do see it, it's great. Okay, so of course it works best if you're at a dark site, especially like Lee, for example. But first time I seen it was in Arizona. All right, for some of the new members there, just kind of give you an idea. This is the dust clouds right here. Usually what happens is, what keeps it fueled is the asteroids colliding, and of course the comets. Comets keeps its dust cloud going. So, this is a shot in Arizona. That's Jay right there, doing his stuff, right? You can kind of see the white pyramid effect there. I do have a little wider angle here, kind of give you an idea of what it's going to look like if you're at a dark site. So there's the elliptical path right there. All right, and what else? Oh, that's it. That's all I have to say. Okay, something I did forget to mention. Darren and I are trying to set up a member site, especially for a binoculars tour kind of thing. So if everything works out, weather-wise that is, then we'll probably have it sometime next weekend. I know we do have the moon coming up, but for binoculars viewing, it'd be great still. But again, we're trying to get out there as much as possible to view the stars, view the galaxies, nebulous, whatever, because obviously we didn't have much of a year for astronomy. All right, thank you.
Thanks, Brian. Okay, next up, Ian will be sauntering over with his background. Sorry. If I was really prepared, this would be the part of the meeting where I had jokes. I don't have any jokes. Hey, look at that.
Good. Everyone can hear me fine? All right. Let's see. It looks like I've got 7 minutes and 30 seconds. Just kidding.
7 minutes and 28 now.
All right. I've got 4 short items for you folks. Okay. First of all, we're going to talk about the orphan afterglow. Everybody clueless?
Yeah.
Ah. But not for long, right? Okay, it turns out that, as you know, a number of years ago, the DLA got rejuvenated and modernized. Okay, so it's now known as the Karl Jansky Very Large Array. And what has been initiated since that time is a number of sky surveys. And one of the interesting things that people do, of course, is when you start a new survey, you have a look at objects that you've had a look at before. And one of the very interesting things that happened this time around is you have a look at 2017 as compared to 1993, which was the old data from the DLA. It's no longer there. All right, so they actually went looking for evidence of that object in the intervening times, and they found this is what they found. Now, the very interesting thing about the 1993 image is you have a look at the energy that's coming from there. It very closely matches those for your blazars. Right? And so there's a thought then that since you actually find this in a dwarf galaxy, which is where you find these gamma ray bursters, that in fact it is associated with light. And so the interesting situation arises then is that we can actually detect these objects, okay, basically by their afterglow. The issue with the gamma ray GRBs, okay, is that we're still working out what these things are all about, but essentially the model works that when you're detecting these things, you have to be in the line of sight for these jets that are coming from the original object. So unless you're in the line of sight or near the line of sight, you're not going to detect these. So now we actually have a means of basically detecting it after the event. So this is very exciting Because now, before, what you had to do is make some estimates on how many of these kinds of objects that you actually have. Basically, you have go through some statistics, you do some sampling, and you get some idea of what the population would be. So this actually sort of nails things down a little bit better. And also, as you saw from that series of 4 images, is that there's now an indication you get some notion of the evolution. Before, you had to rely on sort of the theory about how these things might change over time, and now you can actually get some real data on what's going on. Whoever thought I was going to talk about zombies? Well, as you probably gathered, astronomers often have a quirky sense of humor. All right? So, you want to see what an astronomical zombie looks like? Thank you for that. Sometimes, yes. Sometimes when you get up in the morning, yes, looking in the mirror does the job. This is, in fact, a photograph that was taken by Barnard of the low overlooking nebula in 1905, and he had a 10-inch refractor. All right? It turns out that there's lots of celestial images available that, if you like, are not online accessible. Okay? So we have lots of data, okay, that we can't access in a very nice way and compare. So, for instance, you have to look at this from 1905. It might be kind of nice to compare this with a modern day picture, all right, especially in newer wavelengths, okay, wavelengths which are now accessible to us. Zooniverse started a project, okay, which they called Astronomy Rewind. And the project has a look at something like 30,000 celestial images, okay, from old journals and whatever. And of course, it's a citizen science project. Okay. So they've gone through basically the journals, digitized them, and categorized them. So the first phase is now finished. All right? And the categories were basically single images with coordinate axes, multiple images with coordinate axes, and then those with no coordinate axes. Okay? Now, if you've got coordinate axes, okay, and that means it's very easy to make the comparisons. And the other ones, the other 20,000 have yet to be sorted. Okay, so that's a little bit more challenging. So that's the sort of the next stage. The plan is to make this available to the Worldwide Telescope. All right, and so this material will actually be online and really accessible. Well, what sort of things can you actually do with this? I should sort of back up for a moment. Let's back up. Okay, so when Barnard actually published this in the journal, he said, okay, the light stuff you see is relatively transparent. Okay, the dark stuff is dust. And so it's blocking out the starlight behind. And believe it or not, at that time, I mean, this is something we sort of take for granted now. At that time, this was hotly debated. Okay? And of course, now what we can do is we can have a look at the wise, if you like, image, okay, of this time, and we can superimpose this on the infrared. And of course, as Jay talked earlier on, WISE was a good dust detector. All right, so here you've got it basically fully opaque, okay, slightly transparent, okay, and a little bit more transparent. And so now what you see is those dark regions, okay, that Barnard said were dust. There they are, definitely dust. Okay, it looks like I'm not going to make my thing here, but maybe I will. I always like to introduce a little bit of historical astronomy here. In 1670, okay, a nice bright star was found near the head of Cygnus. It was observed by the astronomer Hevelius, and also let's see, the other fellows have, I think, a Jesuit. All right. And of course, as you might have known out about that time, they were keen observers. Now, the very interesting thing about this object is that it was nice and bright in 1670. It faded. It came back in 1671. It faded. It came back in 1672. It faded and disappeared. So this isn't really the kind of a behavior you expect with nova. So people have actually been looking at for this object for some time. Right? And more recently, okay, using ALMA. Okay? Basically the millimeter, sub-millimeter array in the high desert in Chile. The object that they were looking at, okay, has actually been designated as C.K. Vulpeculi. And so this is the sort of thing that you can actually see there now. Prior to this time, okay, there was some sort of evidence of something there. This is probably the nice highest resolution image we have of this particular object. Now, it's really quite curious because the materials of which it's composed are a little bit odd. I mean, where does one find radioactive aluminum, for instance? Okay, and lithium and stuff like this. So the proposal is that in fact what we are observing is the aftermath of a collision between a white dwarf and a brown dwarf. Okay, you know, brown dwarfs, they don't cook materials too well. All right, and so you can end up with some rather exotic compounds in there, and because of course the white dwarf is much more massive, the brown dwarf, if it's colliding with it, basically that material gets shredded. Okay? And of course this will be a fairly violent event, so you can in fact produce things like radioactive aluminum. So this is the current model for explaining this. And so the authors of this particular paper claim, of course, that they've solved the mystery. But as we all know, the mysteries always continue. Okay, I've got an interesting pick of the month. All right, and something I probably don't show all that often. It's a telescope. Okay, but in fact, it's a telescope with a difference. It's actually one of a set of 4 telescopes. And it's rather odd in a way, in that the actual telescope is, if you like, the Earth's atmosphere. All right? And all this thing does is detect some light from basically interactions in the atmosphere. Right? So if we have gamma rays, and in particular, this particular one is looking at the lower energy gamma rays, colliding with the Earth's atmosphere, okay, a number of reactions occur, and one of the things that does happen along the way is you get some faint light emitted, the Cherenkov radiation. And that's what this particular telescope does. And so we've got, if you like, an Earth-based gamma ray detector. And so, 4 minutes overdue for the break. That's all for this evening.
Okay, don't get up yet. Not yet. Wait for it. Okay, refreshment break, go. We'll be back at 9 o'clock. We have slightly more professional Brendan here to talk to you. I am here tonight to talk to you about an event that happened when I wasn't even close to being born. There's a few of you in this room, I won't say who have come up to me and said, yeah, I was around for that. I'm like, well, actually kind of close. One of the things that, so as a kid growing up in the 90s, 1990s, I mean, I fell in love with, you know, with space, astronomy, and all that, and spaceflight was a big thing. And I was actually really fortunate that Apollo 13 came out when, oh geez, I think I was probably like 13 or 14 or something like that, so it was like the perfect age, right? And I got really into that, and I dove, you know, I kind of went off the deep end a little bit into the whole like space program and stuff like that, so I always had a real passion for it. But one of the things that I really, you know, thinking now, looking back on it, was just how much emphasis there was on the Apollo 11 moon landing, right? And I'm sure a lot of you probably run into this where you talk to people and you know, they're like, wait a minute, we went to the moon more than once, you know, kind of thing, right? And it's like, yeah, went a whole bunch of times, you know. And the Apollo 8 mission in particular, though, it has a lot of there's a lot of interesting history to it that I don't think was, you know, potentially was really well known back at the time. So hopefully enough. I mean, there's going to be a lot of stuff in here that you're used to, but it's like reading a good old book, right? The inspiration for doing this actually came from the most recent issue of Sky News, which, you know, you can hand out to your friends here. Now, a caveat, the actual, you know, the 50th anniversary of this is in December of this mission. Right now is actually pretty close to the 50th anniversary of Apollo 7. And there's a lot of really interesting stuff to talk about with Apollo 7, which I'll get into just a little bit. But Apollo 8 was definitely, in my mind, you know, the big one that I wanted to talk about. I could have saved this for December, but you know, sometimes the way that things work out with you know, speakers, this is just where we ended up. So I'm just trying to get ahead of the curve, really. So I do recommend checking this out, though. There's some good pictures in there, and I'll be going into quite a bit more depth. But before we do that, we do have to go through a little bit of the history of NASA. I'm not going to get into a lot of the space policy administration side of it, and you know, NACA and all that kind of stuff. I'm not even going to throw up the Kennedy speech or whatever. There's a lot to talk about there. I won't talk about any of it, but here's a brief recap. So, from 1958 to 1963, NASA had Project Mercury. This was effectively taking a man, sticking him up in this tiny little capsule up here, launching him in a Redstone or Atlas rocket. One could go, one basically could only arc, the other one had enough juice to kick them up into orbit, and that was actually John Glenn's first flight, where he actually orbited. The Russians were able to do that on their first, well, what we believe to be their first shot. Anyway, but yeah, so they launched the dude up and spun the thing around, and then it came back and landed in one. Right? Pretty basic. But it showed us a lot, and taught us a lot about what humans could reasonably get by with in space. Project Gemini, we stepped it up from 1 astronaut to 2 astronauts. You'll notice that this program was running in parallel, so all of these programs, Mercury, Gemini, Apollo, they were running in parallel. The Gemini astronauts were in a slightly larger tin can. There's really no space for them to move around in here, and I'll talk a little bit more about how that plays into this later. Project Gemini, the goals were pretty straightforward. Extended duration, command Earth orbit, extravehicular activity. So Ed White was up there, he was floating around in space. So they got out of the ship, and they also did space rendezvous and docking, which was a major challenge. I don't think a lot of people here have played the Kerbal Space Program, but it's a game where more of a simulation really, where you try to recreate spaceflight. It's wonderful. I highly recommend it. It's a lot of fun. But it's also a thing where you learn how hard rendezvous and docking are. There's a real problem where the faster you go, the higher you go, right? And the slower you go, the lower you go. So there's a lot of math that has to be worked out in order to make it happen. So they were able to achieve this over the course of 10-man flights. I say doubled there because it's two dudes in the thing. So, anyway, so that was Project Mercury and Project Gemini. So this was the capsule they used for Mercury, the capsule they used for Gemini, and this was the Apollo one. Here are the rockets. Okay? The big thing to point out here is the dramatic, absolutely insane scope increase in complexity when you go from these two to this, right? Gemini proved out a lot of the things that would need to be done to get men to the moon, but it didn't include a lander, and it didn't have a lot of these things going on all at once, right? So a lot of things that had to happen in concert for all of this to work out. I don't have the exact quote, but reading Chris Kraft's book, who was a NASA flight director and eventually became the guy who basically ran the whole mission control down on the ground. When he moved from Project Gemini to Project Apollo, he commented on just how much of a disorganized show it was. It was a real mess when he came into it, and that mess it had some unfortunate consequences. So this is the Apollo 1 crew. So NASA was really pushing to get these guys launched by February 21st, 1967. And there was a real push to get it to happen, and they were really moving fast on it. And what happens when you move fast in engineering? Screw up. So there's a lot that can be said about the Apollo 1 fire. I'm not going to get into it. But the end result was, tragically, those 3 men lost their lives on the path. They didn't even get into space. What they were doing was called a plugs out test. And the whole idea is that you separate the capsule as if it would be in space. But the problem was that they were operating in a high-pressure, 100% pure oxygen environment, which is what they were going to be operating in space, minus the high pressure, right? And you can blame it on testing in pure oxygen, but if you go and read any of the reports of this stuff, there were a ton of mistakes made along the way that contributed to this. So it really hurt NASA a lot. They learned extensively from it. It was a pretty costly thing to learn from, but it did eventually make them better. They thought about what they were doing, how they were doing it, a lot more carefully, put a lot more checks and balances in place. And after a bunch of back and forth with Congress, they were able to get themselves back on the go. So once that was back, once NASA was back up and running, we get to the Apollo 7 launch, which happened 50 years ago yesterday. So this is a lot, so this is basically a year and a half later, and NASA hasn't sent anyone into space, right? They were launching astronauts on the regular with Mercury and Gemini. They were launching them up there pretty well every few months, right? But when it came to Apollo 7, this is the first thing they'd done in a year and a half. There was a lot of consternation about it. They had a lot to do if they wanted to keep the whole program on track to get men to the moon. They had to test life support, propulsion. This is a whole new spacecraft, right? That they had to test. There's a whole guidance and control systems. They would be flying. Eventually, they would these not on this mission. This mission would just be orbiting the Earth, testing all this stuff out. But they spent I forget how many days it was actually. I don't have it written down, but something like probably about 10 to 14 days or so orbiting the Earth, testing all this stuff out. There was a slight mini mutiny that happened. They got a little fed up with how things were, and the commander of the mission, Wally Schirra, had a little bit of an attitude to him as well. Interestingly, and I won't get into the details of it, but none of these 3 men ever flew in space again. Actually, NASA got quite upset with the whole situation. So there's a story there. But, so for Wally Schirra, it wasn't a big deal, but for the other 2 guys that were rookies, hurt them a little bit. Yeah. Anyway, funny history or something like that. Anyway, so the original plan for Apollo 8 and 9. So we had Apollo 7. So and to be clear, so there was the Apollo 1 fire, the Apollo 2 and 3, those numbers just weren't used. And then 4, 5, and 6 were unmanned test flights, right? So they were, and only one of those was actually a test of the Saturn V rocket, which I'll talk about, which we'll get to when we get to Apollo 8. So Apollo 8 and 9, the actual initial plan was to have James McDivitt, Dave Scott, and Rusty Schweikart doing a first piloting of the lunar module in low Earth orbit. Okay? The thing with the LEM, right? This is the thing that was going to be carrying them down to the moon. So they needed to pilot it, make sure that everything worked, check it all out, make sure it was flight ready and all that, right? And then with Apollo 9, they had Frank Borman, Michael Collins, and Bill Anders doing a second piloting of the lunar module in LEO. There was an additional test, which was to test the re-entry that they would experience coming back from the moon, which would be at a higher velocity and a different angle. So there was a whole technique that they were going to implement to actually to go through this. So that would be the additional thing that Apollo 9 tested. But for the most part, these guys were kind of annoyed because, okay, well, they already tested it. Why do we need to test it again? But NASA, after Apollo 1, was pretty shy about taking any unnecessary risks. So that was the original plan. Unfortunately, Michael Collins, he suffered a herniated disc and had to get surgery. Well, thankfully, every Apollo mission has a main crew and a backup crew. So they slotted in Jim Lovell. Spoilers if you've seen Apollo 13, or it's a name you should know. So I'm going to go back in time a little bit to Gemini. So that's Frank Borman, and that's Jim Lovell. Okay? So these two that are now meant to be flying on this Apollo 9 mission actually flew together back on Gemini 7. Flying on Gemini 7 was basically drawing the short straw. That mission was to test long-duration spaceflight in this thing. For 14 days, these two men sat in here. I mean, floated a little bit, right? There wasn't really any room to move around. Waste management, which I'll talk a little bit later, yeah, that wasn't fun, right? Like, dude was sitting like right next to you, right? Yeah, to do it, kind of thing, right? There's a funny, actually, well, Frank Borman apparently, he held out for, I think, something like 12 days. Yeah. I don't think that was probably the best move. Anyway, they weren't consuming a lot of food out there either. But anyway, but they were out there for 14 days together. But anyway, so these guys had some experience together. Gemini 7 was also interesting because they also did a rendezvous with Gemini 6, I think it was. Yeah, Gemini 6. So what they did was they launched Gemini 7, and then like a week later got Gemini 6 up, right? Which is a really impressive feat for NASA because it launched off the same, basically, off the same path, right? So really, really quite impressive. Or no, sorry, there were two separate paths, but it launched out of the same facility, right? So NASA had never done a quick turnaround like that before. So they actually got within like a foot of each other. It was a huge success. The other thing that allowed them to do was take a look at the spacecraft from the other side. Those wires shouldn't be there. Okay? This is just something that these were not supposed to be flying out like that, but nobody ever knew because you couldn't see it, and what would happen is these guys would just eject from here and then shoot straight back to Earth, right? So this is the problem that they had that they didn't even know about. Okay. Back to Apollo 8. So, like I said, Apollo 8 was originally supposed to be the first testing of the lunar module, and Apollo 9 was supposed to be the second testing of the lunar module. There was a problem with that. The lunar module was an incredibly complicated device. As with many of the things to do with Apollo, I could spend an entire night talking about the lunar module. It's a fascinating piece of engineering. It's also kind of ugly. But it's an amazing piece of technology. The problem was that they had never built anything like it before, and they were Grumman with Grumman, the engineering firm that was making it, was going through all sorts of problems, and they had some major setbacks. And it was pretty evident that the LEM would not be ready until February of 1969. So they're looking at this December launch window, right, when they're supposed to be testing the LEM on Apollo 8, and they're like, that ain't going to happen, right? So, enter George Lowe, a guy that I don't think a lot of people have heard about. He had a brilliant idea. He said, okay, well, we still have a launch window. We've got a crew, right? Why don't we just have that crew, instead of testing the LEM, just don't launch with the LEM, send them to the moon. We can do that. That's what this thing's supposed to do, right? Send them to the moon and then have them come back around. Initially, they had suggested. It's kind of funny. He started off like he tested the waters a little bit, where he was like, maybe we can do this. Like maybe we could just send them around the moon. And then he said, and also put them in orbit, which the administration at the time was not keen on at all, because it's super risky, and I'll talk about why in a little bit. But eventually, as time went on, they kind of realized, this is something we're going to have to test out anyway. It's all ready. Everything that we need to do is ready for it. It's just now June, and we have to make a plan for it. So, the original plan, like I was saying, was this, right? Well, what they ended up doing was they took this crew and bumped them to the February flight, the February 1969 flight for Apollo 9, and then took the, I did that a little bit backwards, but then took these guys and made them Apollo 8.
Huh.
Okay, so Apollo 8 is now Frank Borman, Jim Lovell, and Bill Anders, right? They learned about this in August, okay? Their launch was in December, okay? There was a lot that needed to happen to make this, to send these guys to the moon, right? So I don't know. They were all pretty excited. Interestingly, Bill Anders, that guy right there, because he was the rookie, he wasn't too excited about it because he had actually spent his entire astronaut career learning how to fly the LEM. He wouldn't get to fly the LEM.
Oh, wow.
We'll talk about what he got to do later on. I don't think he regrets it too much in retrospect. Apparently at the time he wasn't too happy, but yeah, you get assigned what you get assigned. They're all military boys. So, like I was saying, there's a whole bunch of challenges with this. You've got this time crunch now, right? You got to go through a bunch of retraining. The Saturn V had reliability concerns. They launched it once. I forget which number it was, but they had one test flight of it, and they encountered this problem of what they called pogoing, where it was doing this. And part of the problem was that it was, so this is your rocket because it's going like that. That's not good. And what was happening was that the fuel was being expended so much, like so quickly, that it was shifting the weight in the spacecraft, like in the rocket, by an incredible amount. And so what they ended up doing was they actually just ended up filling it with, they ended up backfilling it with, I think, nitrogen, I want to say. Could be wrong about that, but they backfilled it with gas to effectively cancel out the weight loss. So, but they had one test flight of the thing. That was it, of the Saturn V rocket. The other variations of like the smaller Saturn rockets, the ones that took them to low Earth orbit, yeah, they tested those a few times by that point. So that was a concern. Launch window requirements. Now instead of going into low Earth orbit, you got to find the right time to be able to get to the moon. You got to be able to find a right time when the moon will actually be in a phase that makes sense for doing reconnaissance photos. You have to find a time that lines up with with when you're coming back. You want to be landing in the Atlantic or Pacific Ocean, preferably not over the Soviet Union, right? So, a little touchy at the time, right? So this is, so there are a lot of challenges, and this is all on fairly short notice. So for this, they had their computers, they're the size of this room, calculating all this stuff, and then they ended up coming up with the date of December 21st. I think it's December 21st, 1968. So, they also needed to convince the Navy to change their Christmas plans, so they had sent a whole bunch of boys home, for Christmas, and they had to call a bunch of them back to say, hey, you guys are going to be picking up these astronauts. But it wasn't too hard to get that convinced. And also Apollo 7 still hadn't launched. And it did need to go absolutely perfectly. So, which it did, minus the mini-meeting. The Apollo 8 launch invitation. NASA had never done anything like this before, at least not that I'm aware of. And it was, they kind of had I think they had a sense that they knew that what they were doing was pretty big, right? I'm just going to read this out. You're cordially invited to attend the departure of United States spaceship Apollo 8 on its voyage around the moon. Departing from Launch Complex 39 Kennedy Space Center with the launch window commencing at 7 a.m. the 21st of December, 1968. It's pretty flowery. It's, for effectively what is just a, space launch, right? So, there were a lot of people at the launch. Now for the crew, I mean, despite the cordial invitation and all that, for the crew it was the typical NASA stuff of, at 3:56, thou shalt suit up, kind of thing, right? I mean, everything was planned down to the minute for them, right? So, they were not entirely oblivious to the crowds. When, this is actually on its way to this is Saturn V with Apollo 8 on its way to the pad. I forget which astronaut it was. I think it was Jim Lovell, but he commented when he looked out, because they were launching in the morning, and when he looked out, he could actually see this ring of about 1.5 miles of people, and he joked, "Do they know something we don't?" I was kind of thinking about that. Like, you're at the top of this thing, and you look out, and like nobody's near you. Are we the crazy ones? Maybe we're the crazy. No, they're the ones that are wrong. So anyway, so they wheeled themselves out to the pad, and yay, rocket launch. So whatever, they launched a rocket. I have this thing where I can't give a presentation without including a graph. So the point that I actually want to make here was that the launch. So this is acceleration, right? So the g-forces, effectively that you're going to feel, right? And this is stuff for later. Don't worry about it. But this is the stuff that matters, right? So basically, they ramp up to these g-forces, right, pretty quick, right, and come back down. What's interesting is that the rockets that launched Gemini actually had higher g-forces. One of the things, though, is that the Saturn V is a freaking tall rocket, okay? And it has maneuvering to keep the thing, going in a straight line. What that meant was, so you got these gimbals that are controlling this thing to give it attitude control. That was actually causing, at the very top, right? So if you imagine like a skyscraper that's swaying around, okay, well imagine now you've got this immense amount of thrust that's kicking you up, right? What's actually happening at the top, where the astronauts are, is it is shaking around like this, like absolutely crazy, right? So what's funny is that for Borman and Lovell, who had experienced these, like they were expecting like the crazy G-forces of the Gemini launch, right? And it wasn't that bad. I mean, you get the boom, like the thrust, kind of thing, right? But what they weren't expecting was the crazy vibrations that were shaking, that felt like they were going to shake the thing apart, right? So it was a bit of a trip for them. But yeah, anyway, so it was an interesting difference between the two rockets and how that ended up working out. So so this is a diagram I'm going to refer to a bunch, so you don't need to remember all of it, okay? But I'll give you a brief summary of what the plan was. Okay? So you launch from Florida, right near the equator, and then you come up around here. They spent 3 orbits. Okay, so they go around 3 times, and it's basically just prepping, checking stuff out, getting us safe distance away from their booster and stuff like that. And they still have a booster, right? So and then what's going to happen is they're going to fly around here, right? And the booster is going to fire at this point for translunar injection, and it's going to go like this. The booster itself is going to trail behind and head out that way, and it'll just end up in a solar orbit. It's still out there. People have actually gone off and found these things. It's kind of neat. But the spacecraft itself would continue on, and then and on the way you're doing course corrections with your reaction control systems. Right? If you've played Kerbal, you know all this stuff. So one person in the crowd gets that. So as you come in, so you get to so you come in around the moon, right? Now, if your engine doesn't fire, right? So you need to slow yourself down, right? If your engine doesn't fire, right, you actually just end up doing what's called a free return trajectory, right? So this is what the Apollo 13 astronauts ended up having to do, just due to the whole thing that they went through. If it doesn't fire properly, then bad things can happen. We'll talk about that in a little bit. But basically, you fire your engines, and that puts you into lunar orbit insertion, right? And then you spend, and then the plan was to spend, was to do 10 orbits, right, for about 20 hours, and then you burn again. You come back around on your 10th orbit, and you burn again. You do some more course corrections, and you go poop in the water. Simple. Slightly different view of that. So when you're actually, I mean, that's kind of the fun thing about this, is that when you're launching, you're actually pointing, like, you're pointing out to where the, like, you have to basically point where the moon is going to be, kind of thing, right? So, yeah. Anyway. So after the 3 orbits around the Earth, they did the translunar injection. It was about like 5 minutes, 20 minutes.
All right, you want to go for TLI, over. Roger, understand, we're going for TLI.
Now, I wanted to include a lot more of the audio that went back and forth. One of the things that I found was that outside of some of the good clips, and for the record, like, all of the tapes are out there. Like, you can get all the communication between the astronauts and ground control. The quality of it is not great. They were really not digitized in time. So there's a lot of good stuff, but I had a hard time finding a lot of good stuff. So the amount of audio that I was sharing with you tonight is a little bit. But anyway, basically 2 hours into the flight, they started their, this MET stands for Mission Elapsed Time. They made their way into heading for the moon. Looking back, this is actually one of the first shots. This is actually one of the first pictures that was taken. So I was talking about how Bill Anders didn't get to fly the LEM. He ended up becoming the camera guy. He was the photographer for the trip, using a very fancy Hasselblad. But yeah, this was the booster that they used. So what happens is they, so they couldn't see this thing, right? So they're moving along, and then they separate from it right after the burn, and then they flip themselves back around and see where it is. The booster itself was actually getting a little bit too close to them, but they were able to maneuver away from it safely. The other thing they got to see was the Earth. This was the first time that humans had ever seen the Earth at this distance. Up until now, everything was from lower Earth orbit, right? So what they could see was, they could see the Earth, right? But they could not see it as a sphere, right? So this was completely new to human eyes. Right? Now, one of the things that, so as they progressed away from the Earth and made their way towards the moon, some things happened. The windows started to fog up. They couldn't see a heck of a lot. Like, this thing was not really built. I mean, it had windows on it, but it wasn't built for, like a pleasure cruise where you get to go sightseeing, kind of thing, right? Jim Lovell, partway through the trip, commented that it's like being on a submarine, on the inside of a submarine. So, like I said, the fogging was bad. It was getting kind of warm in there. I think it was hovering around 80 degrees on average. They were doing this kind of rotisserie roll thing to try to even out the heat, but really, like, you're getting blasted by the sun, pretty regularly, right? So it was not very comfortable. Despite the size of the Apollo spacecraft, these were the 3 seats here, right? And then this is the lower equipment bay, and that's it. All of this stuff, this is all their life support and everything else. This is attached by an umbilical cord, right? They can't, there's nowhere to go in here, right? So the space that they actually had was about 12 feet in diameter by about 12 feet high at this point, right? It's not very big. They said that it wasn't too bad because, you could float around a little bit, but it was still pretty cozy. This is Frank Borman during one of the TV broadcasts. Interestingly, there aren't. Anders didn't take any pictures of the crew while he was up there that I could find, which I thought was just kind of a funny thing. They did do television broadcasts, so there are images of them up there. But, early on in the flight, one of the things that they learned was that, or one of the things that ground control actually learned was that Frank Borman had a stomach bug. And he had all the fun stuff that comes along with a stomach bug in a 12-foot by 12-foot diameter space. Right? Yeah, they said by the time that they got to the moon, the conditions were rather rife. Thankfully, somehow he managed to get over it, and it didn't get too bad. So this is their waste collection. So if you need to pee, this is what you used, and this is what it sent out into space. And you might be asking, what is the constellation Orion? This is what Wally Schirra coined. He was one of the astronauts on Apollo 7 and a couple of other one other space flight. He coined this as what happens when your urine goes out the spacecraft and immediately freezes in a mist, in a frozen mist. That's what he liked to refer to it as. One of the funny things about this is that it actually caused the spacecraft to drift a little bit, and they had to course correct for it. They couldn't figure out what was causing it, but apparently, spewing out urine is enough to, cause your spacecraft to shift a little bit. So, getting back to the diagram, right? So now we're going to be aiming for the moon, right? We're going to try and get into there. So they're doing these course corrections along the way, and they're getting pretty close to what they call loss of signals, where you go behind the moon, right? You can't talk to Earth. There's no other relay satellites or anything for you to be able to do that. I thought this was pretty fun. This is one of the guys in Nav guys said they must have a lot of faith. They must have a lot of faith in us, trusting that our numbers will put them into orbit 60 miles above the surface instead of 60 miles into it. It's a really tight window. They traveled 233,000 miles to hit a space that was about 60 miles right, off the surface. So incredibly tight. Basically the steps going through for loss of signal. This all happened pretty smoothly. They went to loss of signal around 3:50 a.m. and then 4 a.m. they fired their surge propulsion system to basically put them into lunar orbit. That all worked out great. And then at 4:25 the blackout ended and they were able to radio back to mission control that hey, we're in orbit. Great, everything worked out. There's audio of that. I listened to it on the internet. It's terrible. So when they got into lunar orbit, things did change a little bit for the crew. The roles for them, Borman was still in command and making sure that the SBS could still get them home. So he was doing regular checks on them, making sure that it was still working. Lovell was mapping things out. So he was spotting, he was basically telling them, hey, yes, this is that crater, and that sort of thing. And actually, they were finding a whole bunch of craters that had never been mapped before, which was kind of cool. So they ended up naming a whole bunch of craters while they were up there, informally, of course. And then the International Astronomical Union was the one that decided what was what. And as I said earlier, Anders became the photographer, which ended up being a really cool, fun job. This is just a collection of pictures that he took. You can find all of them on the internet. There's a Flickr page. And there's NASA's website. The Flickr one actually had, this is from NASA's collection. The Flickr page has a lot, and I really like they they look a lot nicer. Yeah, took lots of pictures, black and white, color, right? Got some close-up shots of some craters. We had seen some of this stuff before, but it was all pretty grainy, right? Because it had been beamed back from these unmanned space probes and stuff. I really like this one. I'm sure he didn't mean to get the port window there, but it really gives you this perspective of them flying over the moon, right? It's just this kind of as you're coming back, as they're coming around it. He took a lot of pictures. They're not all winners, right? Some of them didn't look all that great, but as every photographer in this room knows, it's not your gear, right? It's sometimes, if you're in the right place at the right time, you get this. Okay? This is not, okay, so there's a couple things about this. This isn't actually, I'll show you the actual Earthrise picture in a sec. This is not the one that NASA ended up publishing and making super famous. This was the first shot that they took of it. So what's interesting is that this actually happened on the 4th orbit. They couldn't see this on the way as they were coming around on the initial ones because they had a very tight schedule on trying to map out places to land a lunar module in the upcoming missions, right? So this was not on the agenda at all. And when it came into view,
they weren't entirely ready for it. So this was Anders' first shot with the black and white camera, right? And then this was the one that he ended up taking with the color camera. Now, in order to get there, they were actually scrambling to get the color film, right? Like Anders was freaking out because they had no idea that they were going to see this. It was one of the most amazing things that they had ever seen, right? So they scrambled to get the color film and get all that together and snap this, and then NASA corrected it to look like this, right? And yeah, it is just one of the quintessential, like, most famous images ever taken, right? And that's how it came to be. So they had been, so after 3 days in space, this is their 9th revolution, so they're probably at around hour 18 of being in lunar orbit. They were going to do a Christmas Eve broadcast. And none of these guys are public relations people, right? Frank Borman commented there would be more people listening to this than anything ever in history, right? And they knew they were going to do this broadcast a long ways back, and they actually they were trying to figure out, like, the guys at NASA were trying to figure out what to say, and they couldn't come up with anything. And then they ended up reaching out to one of Lyndon Johnson's former, I can't remember what his role was exactly off the top of my head, but basically a guy who's good with words. I think he was a speechwriter, maybe. Anyway, he spent a whole bunch of time trying to come up with anything, couldn't. And the funny thing was that his wife actually came in and gave him an idea, and he said, "Yeah, that'll work." Right? What they went with was a reading from Genesis, which is, kind of a somewhat Christmassy tradition, right? And with a farewell. This was heard by 1 billion people, right? Just for the sake of time, I'm not going to go through the whole the whole Genesis reading, but I did want to just get a sense of, like.
And from the crew of Apollo 8, we close with good night, good luck, a Merry Christmas, and God bless all of you on the good earth.
1 billion people were listening to that, right? 233,000 miles away, right? 3 humans just floating around this hunk of rock, right? That men had never been that far before, right? Yeah, I don't know, it's pretty profound. If you want to listen to the whole reading, it's online. Again, it's the quality. I just didn't want to make you guys suffer because the quality of it is not great either. There's some echoing going on and stuff like that. So, how do we get out of here? So they finished their ninth orbit, and it was actually kind of reflected on that reading and that farewell could have been kind of their send-off if things didn't go smoothly, right? Because if the engine doesn't light while they're in lunar orbit, they don't come home. Nobody's going to save them. That's it, right? So it was a scary time, particularly for mission control, because what has to happen is you have to go through loss of signal, and the trans-Earth injection burn has to happen back here, and then bring you back. So as far as, like, NASA wouldn't know that things had gone smoothly or terribly until after it had happened.
Houston, Apollo 8, over. Roger. Please be informed there is a Santa Claus. Yes, that much now. And burn status report. We burned on time. Burn time 2 minutes, 23 seconds.
So you can't really hear mission control there, but they were basically calling to them and waiting for that signal. They did manage to. They got things like after that, things got a little bit more laid back in mission control, much to the consternation of guys like Chris Kraft, who was the head of the whole mission control center. There's a guy that you'll hear on this next recording. His name's Deke Slayton. He was actually part of the original Mercury mission, but due to a regular heart rhythm, never got to fly. So what ended up happening was he said, okay, well, whatever, I'll stick around at NASA. And he basically made a job for himself. He became basically the astronaut leader, right? So he was the guy that assigned all the astronauts to all the flights and worked with the astronauts and basically did all the selection and all that kind of stuff, right? So, yeah. So you'll hear Deke Slayton talking to I think Borman and Lovell.
Morning, Apollo 8. Deke here. I'd like to wish you all a very Merry Christmas on behalf of everyone in the control center, and I'm sure everyone around the world. None of us ever commit down with a Merry Christmas present to this one. Hope you get a good night's sleep from here on, and enjoy your Christmas dinner tomorrow, and look forward to seeing you in Hawaii on the 28th.
Okay, leader, we'll see you there. That was a very, very nice ride, that last one. This engine is as smooth as glass.
Yeah, we gathered that. Outstanding job all the way around.
So, that was actually a break from protocol as well. And one of the things that, if you've heard the term Capcom, it's a guy, like a person that is on the ground that is solely responsible for communicating with the astronauts. And this is to prevent any kind of like miscommunication in terms of orders and that sort of thing. So Deke Slayton was not Capcom, but he felt like he could get in there anyway. So we're all good now. We're heading back to the Earth, right? Now the thing is that we still need to we still need to thread this needle, right, and get it into the right spot. So in order to do that, they were performing course corrections along the way. So Jim Lovell, who was responsible for making course corrections, they would get sent up from mission control based on the data that they had there, and everything. Basically the computers ran the numbers, and then they sent up course corrections. This basically involved entering verbs and nouns in the form of numbers in a computer. Right? So I mean, these are really, really primitive computers, right? But they're still very powerful. I mean, they're doing an amazing amount of work. But like, user friendliness was certainly not a concern. It's literally punching buttons, into a pad, kind of, right? So yeah, after one course correction, during the trip back, the ship swung straight up 90 degrees. It was basically like they were doing this kind of thing, right? Like moving along, and it just went like, yeah. So something was definitely wrong. So Lovell was supposed to enter verb 3723, noun 501. He entered verb 37, noun 01. You all know what this means, right? So verb 37 means return to Earth, right? That's what they're doing. That's good, right? That's fine. Noun 01 means pre-launch mode. What do you do before launch? You stand up straight because you're going to be flying off into space, right? So what had happened was they had, not only that, it actually wiped the whole computer in terms of where it was. So, so basically, yeah, so what Jim Lovell had told it was, completely forget everything you know. We're now back in Florida on the launch pad pointing straight up. So the computer was like, all right, you got it, right? It did exactly that. Now what this meant was he then had to use the navigational systems on the Apollo spacecraft to do a bunch of star alignments, which many of us are familiar with. And so Jim Lovell did star alignments and basically was able to tell the computer, this is where I am, and they got themselves right and everything was good. Spoilers. When Jim Lovell was on a future flight, having that practice really came in handy. I wanted to, so 4 days into it, they had there was a broadcast. There was a TV broadcast that I want to show you guys. It's a few minutes long, but I'm almost done. So I just want to show you guys this. I think it's kind of neat.
Okay, fine. It looks like you're okay, but somebody else is upside down.
right, that's Jim Wobble. What we thought we'd do today was just show you a little bit about life inside the Apollo 8. We've shown you the beam to the moon, beam to the Earth, and we thought we'd invite you to our home. It's been our home for 4 days. You can see on the deck the instrument panel. We mark off each day on the instrument panel. We pour down and we're working on the 5th day. Of course, we're all looking forward to the landing on Friday. And down here in the part of the spacecraft that we call the lower equipment bay, we have the President's Advisor on Physical Fitness, Captain Jim Lovell, about to undergo an exercise program that we do every day. You notice that he floats around very freely. Just bump his head on the optics of our navigating.
Okay, give me a sense of space. Andrew's head is basically right up against the
Working with an exercise device that's designed to keep the muscles in shape. Another very important function of our spacecraft is the computer. That might be interesting to see what we have here. The display that gives us all the information about our birds, about navigating, and about the velocity that we use during entry and retrofire on Earth orbital mission. You can see it's controlled by a disk key, or similar to a typewriter keyboard, and things that go in and out of that are absolutely miraculous. It's done a fantastic job for us, and Jim Lovell's done an excellent job operating. Area is called the LEB, or the Lower Equipment Bay. And we have our optics positioning equipment right here. We do all our navigation down here by sighting on stars and on the horizons of either the moon or the Earth. And this is where we find out exactly where we are in space and what direction and how fast we're traveling. And our computer, as Frank had mentioned, then takes the information and tells us how to maneuver to get home safely.
Yeah, so anyway, I thought you might find it neat that if you are an astronomer, you can come in handy on one of these space flights, right? Doing those star lines. So they did re-enter successfully. It's interesting because, like I said, that the original Apollo 9 mission was actually, part of it was to test this re-entry method. They ended up becoming the first people to test it anyway, just by virtue of coming back from the moon. But everything went super smooth, and they came down and were greeted as heroes. It was a really big deal. It was a really big deal for the United States at the time, and the world at large. The actual the loss of when they were flying into when they were heading toward the moon, the loss of signal stuff, and then the confirmation that they had actually entered into lunar orbit was covered heavily by the BBC. It was funny, while that was happening, nobody was really awake in the United States. They weren't really paying attention during that time, but it was heavily covered overseas. So the whole world really was watching. The Soviets congratulated Washington using their direct link and all that. They did wait about an hour and a half to confirm that it was actually true. Yeah, so for the world at large, this was a big deal, and for a lot of reasons. So 1968 was not a good year. So Martin Luther King, Robert Kennedy, both assassinated. The Vietnam War this is its 5th year since Lyndon Johnson's escalation, and it wasn't just the United States. There were riots going on in France. There was the Mexico City massacre prior to the Summer Olympics. There was the Warsaw Pact invasion of Czechoslovakia. The whole world in 1968 was in a state of turmoil. And for these guys to fly to the moon and come back and make it back safe was a real testament of human achievement, right? This was kind of the exploration, that we're, the kind of the explorers that we are. Right? And Frank Borman, has talked about this like ad nauseum, but he said it was the greatest telegram that he's ever received. That was from a stranger, just somebody that sent that message to him. So, yeah, so that was the story of Apollo 8. There's a lot of really interesting stuff that I didn't get into because you guys only give me an hour for some reason. So this book was actually the source of a lot of what I talked about, and maybe some things you hadn't heard of before. There's a lot more stuff in there that I recommend. I recommend checking out if you're into this kind of stuff. If you haven't, and if you're really into this stuff and you haven't read these books, I recommend them too. They give you a really good sense of what it was like for Mission Control. So this is Chris Kraft's book, and Gene Kranz was famous for being the flight director, or one of the main flight directors during Apollo 13. If you're not into the book reading, I highly recommend it. No, obviously these aren't documentaries, but they're pretty accurate. They do play some stuff up and get a few things wrong here and there for the sake of just, TV and movies. But The Right Stuff is a fantastic movie that focuses on the Mercury missions, so the first ones. From the Earth to the Moon was an HBO miniseries hosted by Tom Hanks, thank you, and really excellent. It doesn't retread much that happened for Mercury and talks about Gemini and Apollo and really gets into some excellent depth. There's an Apollo 8 episode in there that's actually quite good too. So it does a really good job of diving into a lot of what happened during the whole the Apollo mission. Of course, I talked about a bunch of Apollo 13. And interestingly, if you haven't seen the HBO miniseries, they actually have an Apollo 13 episode. It's completely different than this, and potentially in a way that you might not expect. So I really recommend checking the whole series out, including this that you're watching. There's also In the Shadow of the Moon, which is a series of interviews with the astronauts after the fact. So they all really tie together quite nicely. So I recommend checking those out. And most recently, I really recommend this, Hidden Figures. It was an excellent movie. It's kind of a new addition to the whole swath of Apollo-era films that are out there. There's also a whole ton of other books if you want to read. Like there's the Apollo 13 book as well that Jim Lovell wrote, the same guy who did the Apollo 8 book. There's Neil Armstrong's book. I think Buzz Aldrin. There's a ton of reading out there, so that's just a small sampling of the kind of stuff that you can read about when it comes to this. So it's an amazing amount of history, and I love talking about it. So thank you for giving me the opportunity. I did ramble a little bit, so we're short on time, but if you have any questions, I mean, I can try to answer them. Questions? Yeah. No? Okay, that's cool. Oh, yeah, go ahead.
Just a comment.
Yeah.
There's a book by Chaikin called Man on the Moon.
Yes, that's another.
It's all the Apollo astronauts' accounts.
Yes.
Some of their accounts.
Yeah.
And it's just interesting with Norman. I think it was the lunar burn that would keep them in orbit.
Yeah.
And apparently up to a minute before that was supposed to kick in,
Yeah.
the computers were going to do the burn.
Yep.
And apparently he had his thumb or his hand on that switch the whole time, and if that thing was not going to kick in, he was going to be there on it.
Yeah. Yeah.
One second.
Yeah. Funny thing on that too was that during the launch, he actually protocol was to actually have your handle have your hand on the handle, right? You remember that vibration that I was talking about? He actually got a little scared because he was like, "Oh man, if I pull this thing, it's shit over, right?" So he actually ended up taking his hand off the handle briefly just to make sure he didn't accidentally pull it. Yeah. There's a ton of great little stories in this whole adventure. So. Okay, cool. Yeah, Judy.
One more comment.
Yeah.
I was almost 17. I'm not the oldest one in the room, and I'm not the youngest. That was the best Christmas ever.
Yeah.
We listened to every word. We didn't go to sleep. We slept in the living room, or tried to. We watched the TV and the radio was on, and it was incredible. There were so many kids hyped about anything, space, science, anything. how you pee, how you shit,
Yep.
you know,
Yep.
all of that. It was remarkable, and it was so exciting.
Yeah. No, and that's, I love to hear that perspective because as a kid who grew up in the 90s, right, I didn't really get any of that. You know, like I'm not going to say I feel cheated, you know, but I kind of do. Like I dove into this stuff pretty heavily, right, because I just find it absolutely fascinating, and to me they were just incredible. But what gets me is how little of this miraculous stuff is really known, right? I don't hear about Apollo 8, you know, in popular media all that much. Nobody really talks about it. So, thanks for sharing that. Okay, yeah.
I was just going to say, I was in Dr. Kettner's physics class during the Gemini thing where Glenn went up, and this was from 11:30 to 12:30 noon, and Dr. Kettner, who was referred to as Uncle Max, was interrupted a few times by a transistor radio on the time that John Glenn got into orbit. That was an interesting class.
Yeah.
And I remember it was in February.
Okay, yeah. That was that was the Mercury one, right? The third one.
That was the second one, John Glenn. The first one.
Oh, wait, it was Shepard. It was Shepard and Glenn.
Yeah, Shepard and then Glenn.
Oh, there was something in between there.
Grissom.
Yeah, Grissom was two because that was where the where the hatch blew. There was a whole thing there with Paul. Anyway, so it's 10 o'clock. We do need to wrap things up. So I do appreciate the comments and all that. That was really nice to hear. Darren, you did have something you wanted me to announce?
Yeah, just a couple of quick things.
Yep.
Yeah, I just mentioned.
We'll make this quick.
Yeah.
But
For the binocular only observing thing that we're going to be doing next week, keep your eye open. Brian will be making an announcement. Okay, so I think it'll be really good. If you don't have a pair of binoculars, come out anyway. And if you do have a pair of binoculars, even if you don't think they're up to snuff, bring them out anyway. We'll have fun.
Cool. Thanks. And yeah, the meeting will continue over here at Pizza at Boston Pizza, which is just the one south of here on Penna.